In this position function equation, it says the position function for an object is given by this equation, where s is measured in feet and t is measured in seconds. Find the velocity of the object when t is 2 seconds. So, first off, you have to know that your velocity is your first derivative of your position function. So therefore, your generic velocity that works everywhere is 12t plus 240, just taking the first derivative. Now your job is to evaluate that where time is 2 seconds. So you're going to plug in a 2 wherever you have a t, and you only have one t. So doing this math, this is 24 plus 240, so that's going to be 264. And since I'm giving you units, you need to give me back units. So the velocity at 2 seconds is 264 feet per second. And that is your answer. In question number 20, we have 4 parts. So the initial question says a coin is dropped from a height of 750 feet. The height is measured in feet at time t, measured in seconds, is given by s equals negative 16 t squared plus 750. And they say to round to the nearest tenth when needed. Okay, question A. What is the average velocity? So even though they're saying the word velocity, do not take the first derivative. You're going to take the position at time 3 and the position at time 1 and evaluate those. So this is your equation. Let's get rid of some of the other stuff. So I'm going to clean this up for a sec. Alright, so I cleaned up the rest of it. Let's figure out average velocity. So I've drawn our equation. I've graphed it for you. And I've also labeled where x is 3 and where x is 1. And I've drawn the secant line connecting the two. So you're basically finding the slope of that secant line. Okay, so you're going to say, I want negative change in s over change in t. And so I want s of 3 minus s of 1 over 3 minus 1. So s of 3, when you plug in the 3, you should get 606. When you plug in the 1, you should get 734. And then 3 minus 1 is 2. So that's going to be a negative 128 over 2, which gives me a negative 64. Again, I give you units, give them back to me, feet per second. So see how that's a velocity even though I didn't take the first derivative? So it makes sense that the slope of this line is negative because of what I see. So here is your answer to part A. Let's go on and do part B. Okay, looking at part B, I have left the answer to part A up there and how we got it, or at least what equation we used. So now I see that they want instantaneous velocity. So when they do instantaneous velocity, I want the first derivative. So I see that my s of t is negative 16 t squared plus 750. Therefore, my s prime of t is just going to be negative 32t. Okay, if they want the instantaneous velocity when time equals 3, then I'm going to evaluate this first derivative at 3, and I get negative 32 times 3, which is negative 96. And again, give me the units, feet per second. And part B is done. Let's move on to parts C and D. Looking at part C of this question, how long does it take for the coin to hit the ground? So if it's going to hit the ground, the height above the ground is going to be 0. So I want to know what time, so I'm going to put a little X right here. This is what I want to know. I want to know when that hits the ground. So what I'm going to do is I'm going to take my position function to do C, and I'm going to set my position function, which is negative 16t squared plus 750 equal to 0. Alright, so when I do that, I end up getting t squared equals 750 over 16. Taking the square root, I get approximately, if I round to the nearest tenth, 6.8 seconds. Now I get positive and negative 6.8 seconds. Clearly I want the positive because I'm looking for positive time. So it takes 6.8 seconds to hit the ground. Alright, so that's how long it takes. So that's my answer to C, no problem. Then for D, what is the velocity when it hits the ground? Alright, so I'm going to take my velocity equation, because what I want to know now is what is the slope of this curve when it hits the ground. Okay, so I want to evaluate the time of 6.8 and see what the velocity would be then. So take your velocity equation, and we worked on that in part B, but if for completeness, let's just say that, we'll do it again, S prime equals negative 32t. So I want to know what is the velocity at the time it hits the ground, and that time is 6.8 seconds. So that's 32 times the 6.8, and that gives me a velocity of 218, rounding to the nearest tenth, 0.9, and again, and oh, this is negative, by the way, so it has to be negative, because this is negative. So negative 218.9, and give me units, feet per second. Alright, so that problem is done.